We're very pleased to be with you here today talking about our products. I see that we have a number of customers that are attending the audience, and for that I thank you. And for those of you who don't know our products, I will introduce you to them today. It all starts with the GAIN meeting. Photodigm is a vertically integrated company with our in-house wafer fab offering chip to package solutions. And on the right there, you see a graphic of our DVR Laser product. It's about 2 millimeters long, 1/4 millimeter wide, and is truly designed for quantum. It is a single frequency laser with line widths on the order of several hundred kilohertz or less. It's tunable with about a 2 nanometer tuning range without a mode hop. And it's a monolithic integrated device capable of producing up to several hundred milliwatts, depending on the wavelength, at the specific transition is necessary. It's used by researchers today worldwide, and it's scalable for OEMs tomorrow. And it is that scalability, that semiconductor scalability, that will enable OEM products for the future. On the next slide, we introduce Photodigm DVR lasers as a platform technology supporting a quantum platform of clocks, magnetometers, gravimeters, communications, and computers. There's something like over 100 wavelengths ranging from the vacuum UV to the mid-IR that have been proposed for and used for quantum applications, probing quantum transitions. That may be suitable for an R&D application, but as products develop, there's got to be some down selection of those wavelengths. And we see specifically 3 pillars supporting the quantum technology. And those pillars would be 369 nanometers for the terbium ion, 780 nanometers of the rubidium D2 line, and 852 nanometers, the cesium D2 line, as being the primary workhorses here, supported by a number of other wavelengths. Those other wavelengths are shown on those term diagrams, and for many applications, in order to probe the complete physics package, you do need wavelengths such as 776, 778. Other applications may require 935, and we can do all of those within our wavelength range using the standard Photodigm DVR architecture. In addition, we produce devices such as 808, which can be used for frequency doubling, for 404, and some of those other blue wavelengths that support those some of those other gallium nitride type wavelengths. The 369 is not a product at this point, but it's on our roadmap for future development, and we see that as very key for subsequent work. On the next slide, you'll see our market-driven product development over the years. We introduced our first 780 nanometer lasers for rubidium and metastable helium in 2007. And over the years, because we are a fundamental laser producer, able to produce devices with our specific wavelengths out of our fab, we have increased our scale of products. We have over 40 wavelengths within that quantum range that we've delivered over the years. We've introduced higher powers, several hundred milliwatts of single frequency power at depending on the wavelengths. We've produced multiple package types, and several years ago we introduced our extended mode hop device, which has the 2 nanometer tuning range without a mode hop. We've got devices that operate at high temperatures, and we have a very active roadmap going forward for further support of our customers. And on the next slide, we give you an introduction of our support strategy. Obviously, in today's environment, the web is a very important part of our support strategy, and you'll see that on our website. You can see applications notes, product data sheets, and other information. One of these days, we'll be back to trade shows. Hopefully in 2022, we'll be back there doing our worldwide march of trade shows. And we're always supported by our sales and applications team. Bob Davis, our Vice President of Sales, Esther Moreno, our Inside Sales Manager, and Annie Zhang, our Director of Product. And I'm sure as our customers know, you know these individuals and you've talked to them and they're always ready, standing by to support your needs. We have distributors in key international markets, and we are a charter member of the QED-C. And I'll close out by saying that every device that we ship out for quantum for a specific transition is certified to be on that transition and sealed and certified by our Director of Products, Annie Zhang. Thank you very much.
So I had some questions here prepared, but one question came up in the chat, and I know Celia, can you go back to the wavelengths? Yeah, so you have the 369 under development. I heard you say that it's early days there, but David asked if you could expand. Anything you could expand on that would be appreciated.
Well, at this point, let's just say that our exploration and evaluation of the marketplace opportunity has a terbium ion as a very key wavelength. There are 369 or gallium nitride lasers, Fabry Pros, that are available today. But the important factor to keep in mind here is that DVR lasers, semiconductor lasers, are really ultimately enabling OEM products. These are mobile devices and ones where you can't accept a mainframe type laser. So we see the terbium ion as being a very key factor. We've got it on our roadmap, and we have a very detailed plan to move that forward.
Great. And so is that in the same, I'm just going to ask because some people might be thinking this, is that going to be in your standard DVR packaging, or is there anything else that's going to be associated with that because it's a tough wavelength? It's
a tough wavelength, and we don't believe that it is a frequency doubled wavelength that is readily used. So it'll be a direct product.
Okay. Okay, you have time for one more question. This is a little bit more open-ended, but DVRs have a great track record in telecom wavelengths, datacom wavelengths, of being extremely reliable and high volume, right? And how do you see in working with other markets? I can understand that in spectroscopy and that sort of thing. But in the quantum space, a lot of the volumes right now are probably low for you, right?
They're low volume products, yes. And generally, the quantum wavelengths are typically research wavelengths. So
right.
they have lower volumes. Where we see the higher volumes is in the OEM applications, which we call adjacencies. And I didn't go into that discussion today, but it's the adjacent applications such as Raman spectroscopy, terahertz spectroscopy, and others that are providing more significant volumes today.
Right, but as I think for the audience here, I think what's important to note as some of a lot of quantum research is going on, but as certain specific quantum technologies start to enable quantum computing, quantum sensing, quantum communication, and atomic clocks, as that starts to get to more of a deployable nature, is that something, at higher volumes, once you get into development, is that something that you see as supporting in the future?
Absolutely. It's fundamentally a semiconductor is a scalable product. You make one, you make 10,000 at essentially the same cost to manufacture. And clearly, that's why the importance of the down selection. And the down selection, I think, it will be driven by the need to have to move out of the research and laboratory and into real mobile, real fielded solutions. And
Yeah,
that
yeah.
require a scalable, cost-effective semiconductor.
Yeah, thank you so much, John.